Hi, this is Mrs. Zhu, and we're going to be working on homework number 12, the worksheet about scientific notation. I'm just going to be working through the odd questions, and then in class we will go over the even answers and work those out together. Number 1, I always start with a number, then times it by 10, and then another, and then an exponent. So it's going to be something times 10 to the power, and that's how I write the format for scientific notation. In class, I had said that this number should be between 1 and 9, but actually it should be between 1 and 10. Okay, no bigger than 1, but smaller than 10. And then this number can be either positive or negative. Okay, so for number 1, when I drop the zeros in the front of the 2, and then I just write 2. And because 2 happens to be in front and between 1 and 10, I'm just going to write 2, and the decimal can go there. Times it by 10 and take it to a power. Now the power is found by me counting how far the decimal spaces are away from one another. Now because there's already a decimal here, and then over here I'm going to add a decimal back here because of the 2 point. I'm going to count the spaces. I have 1 space, 2, 3, 4, 5 spaces away from each other, 5 spaces. And so then I'm going to put the exponent 5 next to the 10, and I'm going to put negative 5. Now the reason it's negative is because 0.00002 is a small number. So small numbers have negative exponents, and large numbers being numbers like 1 or 10 or anything bigger than 1, 100,000, million, billions would be positive exponents. So in number 3, I'm going to take 4,280,000, and I'm just going to take the 4 and the 2 and the 8. Now 428 is not a number between 1 and 10, so I need to put a decimal somewhere to make it between 1 and 10. Now if I put it in front of the 4, 0.428 is not between 1 and 10. If I put it in between the 2 and the 8, 42.8 is not between 1 and 10. So actually the decimal needs to be right between the 4 and the 2, because 4.28 is between 1 and 10. So now we can times it by 10, find out what my exponent is by figuring out where my decimals are. Now there's 1 in front between the 4 and the 2, and in the number 4,280,000, there's actually a decimal back here, even though they don't write it. So then I'm going to count how far those decimals are away from each other. 1, 2, 3, 4, 5, 6. There's 6 spaces away. So that's going to give me the exponent 6, and it's positive because billion is a big number. Okay. Number 5, I'm just going to take the number 5. I could take 50 and put a decimal there if I'd like, or I could just drop the 0 altogether, and then times it with 10. Now the decimal is behind here, but I decided to put it in after the 5 instead, so there's only 1 space, so positive 1, because 50 is a bigger number than 1, which means that this exponent 1 will be positive. Number 7, I'm working now backwards and writing it in standard notation, so I have scientific notation, but I'm writing it in standard. So because it says negative 2 as the exponent, that tells me I'm going to go left 2 with a decimal. So I'm going to take the decimal, 7.27, move it 2 to the left, 1, 2. It'll end here. And I'm going to add a 0 in between that to give that place, hold that place. So the answer, 0.0727 would be my final answer. Number 9, I'm going to look at the 3. That tells me 3 spaces to the right because it's positive. So I'm going to take 5.6, move the decimal 1, 2, 3 spaces to the right, end it there. Add 2 zeros. Answer 5,600. I don't need the decimal in my final answer, but if I want to put it there, I could put it there, just in case. Okay, and number 11, I look at the negative 1. That means 1 space to the left is where I'm going to move the decimal. So 2.4, decimal goes left 1 space, so the decimal ends up in front of the 2. Final answer is 0.24, and that's my answer for 11. Number 13, I'm simplifying, so I'm going to multiply the 7 and the 6 together, giving me 42. I'm going to multiply the powers here, 10 to the first times 10 to the negative 5. And if you remember that when I multiply powers, I want to add the exponents together. So if I add 1 plus negative 5, if I use T for teams, that gives me negative 4. So I'm going to have 42 times 10 to the negative 4th power. I'm going to leave it like that because I do want to write it in scientific notation, and that's not yet the answer, but I do want to actually work it out tomorrow in class more. Okay, so I'm going to just keep it like that for now. 15, I'm going to multiply 8 times 7.4. If I multiply decimals, I put the one with the larger digit on the top and the smaller digits on the bottom. So if I multiply that, I get 3, 5, 9. Because there's one space here, I'm going to go one space this way and get one space once. And then I'm going to get 5, 9.2. Then I'm going to multiply the powers times 10. And if I multiply powers, I'm going to add the exponents. So negative 5 plus negative 3 is going to give me negative 8. So there's my final answer there. It's not final yet, but we're going to talk about that more tomorrow. Okay, number 17, multiply 5.4 times 8.6. Okay, I get 46.44. Then I'm going to multiply my powers, times it by 10. The bases stay the same. Add the exponents, and I get 3 plus 3 is 6. So that's my exponent for this answer here in number 17. Okay, and then I want you to try 19 all by yourself using the book, the section, and we'll kind of go into a little more tomorrow and then do the evens in class.